In this module, we'll be covering data pre-processing techniques, led project. Hello and welcome to the channel. Whether you're new to the world of artificial intelligence or already on your journey to mastering machine learning, you're in the right place. Our channel is your learning companion in exploring AI, data science, and machine learning, with easy-to-follow explanations, real-world examples, and hands-on insights. In this special extended episode, we're diving deep into Module 2, Fundamentals of Machine Learning. In this module, we'll be covering data pre-processing techniques, evaluation metrics for machine learning models, and an introduction to the key Python libraries you'll use in ML like NumPy, Pandas, and scikit-learn. This video is crafted to give you a solid foundation, with over 2.5 hours of valuable content. So grab a coffee, settle in, and let's get started. Introduction to the topic: machine learning is changing how we live, work, and think. But before a model makes predictions or recommends the next movie on Netflix, there's a lot going on behind the scenes. From cleaning and preparing data to choosing the right metrics to evaluate performance, and finally to implementing the right tools, each step is crucial. In this session, we're going to dissect 3 foundational pillars of effective machine learning practice. First, we'll tackle data pre-processing, a critical step in which raw data is cleaned, transformed, and made ready for modeling. Next, we'll explore evaluation metrics, helping you understand how to measure your model's success and diagnose issues. Finally, we'll give you a tour of essential Python libraries, NumPy, Pandas, and scikit-learn, so you know exactly what tools to use and how. By the end of this video, you'll not only understand these topics, but you'll be able to confidently apply them to your own ML projects. Main content, Section 1, Data Pre-Processing Technique. Data pre-processing is one of the most important and time-consuming steps in a machine learning pipeline. In fact, data scientists often say that they spend 70–80% of their time just cleaning and preparing data. Why? Because machine learning models are only as good as the data you feed them. 1. Handling missing values. One of the first problems you'll encounter is missing data. For example, if you're working with patient records and some entries don't have an age listed, you'll need to decide how to handle that. Common techniques include removing rows with missing values, if few, imputing values using the mean, median, or mode, using advanced methods like KNN imputation or model-based imputation. 2. Data normalization and standardization. Raw data may have different scales. For instance, a dataset might contain age, 0100, and income, 100,000. Without scaling, the model may assume income is more important just because of its larger numbers. Here's where normalization, scaling between 0 and 1, and standardization, scaling based on Z-score, come in. 3. Encoding categorical data. Machine learning models generally can't handle text directly. If you have a gender column with values, male and female, you'll need to encode these values. Common techniques include label encoding, one-hot encoding, target encoding. 4. Feature selection and extraction. Not all data columns are useful. Some might be irrelevant or redundant. Feature selection involves choosing the most important variables. Feature extraction, on the other hand, transforms data into new formats, like using PCA, principal component analysis, to reduce dimensionality. 5. Dealing with imbalanced data. If you're working with a fraud detection model and only 1% of transactions are fraudulent, your model may learn to always predict, not fraud, and still achieve 99% accuracy. But that's misleading. Techniques like resampling, SMOT, or class weighting help address this. Real-world example. Imagine building a customer churn prediction model. Your dataset includes customer age, contract type, monthly charges, and whether they left the service. Before you do anything, you'd need to clean the data, convert text to numbers, scale numeric values, and potentially balance the data if most customers stayed. Section 2. Evaluation metrics for ML models. Once your model is trained, how do you know if it's doing well? Choosing the right evaluation metric is essential. 1. Classification metrics. Accuracy, the percentage of correct predictions. Simple but not always reliable for imbalanced datasets. Precision. Out of all predicted positives, how many were actually positive? Recall. Out of all actual positives, how many did the model catch? F1 score. The harmonic mean of precision and recall. Confusion matrix. A table showing true positives, true negatives, and false negatives. Scenario. In a cancer detection model, high recall is more important. You'd rather catch all possible cases, even if it means a few false alarms. 2. Regression metrics. Mean absolute error, MAE, the average absolute difference between predicted and actual values. Mean squared error, MSE, squares errors to penalize larger ones. Root mean squared error, RMSE, the square root of MSE. R squared, measures how well the model explains variance in the data. Example. If you're predicting house prices, MAE gives you an idea of the average error in dollars, which can be very intuitive for stakeholders. 3. Cross-validation. Instead of testing on one train test split, you divide your data into multiple folds and test your model multiple times. This gives a more reliable performance estimate. Real-world scenario. Suppose you develop a loan default prediction model. You'd use classification metrics to determine how well it separates defaulters from non-defaulters, and use cross-validation to ensure your model isn't just lucky on one specific dataset split. Section 3. Introduction to Python libraries for ML. Now that you understand how to prepare your data and evaluate models, let's look at the tools that make machine learning in Python possible. 1. NumPy, the foundation of numerical computing in Python. It offers powerful data structures like arrays, and functions for linear algebra, random number generation, and more. Example. Use NumPy to compute mean and standard deviation or to initialize weights for neural networks. 2. Pandas, ideal for data manipulation and analysis. It introduces the data frame, a 2D structure that allows for easy data cleaning, filtering, joining, and reshaping. Example. Loading a CSV file, filtering customers with monthly charges greater than $100, and summarizing the average churn rate. 3. Scikit-learn, the go-to ML library for beginners and professionals. It provides easy-to-use tools for pre-processing, model selection, training, and evaluation. Use cases. Building a pipeline that standardizes data and applies a classifier. Performing grid search for hyperparameter tuning. Applying cross-validation and interpreting results. Scenario. Imagine building a pipeline to predict student performance. You'd use Pandas to clean the data, NumPy for any math-heavy manipulation, and Scikit-learn to build and evaluate your model, all within a few hundred lines of code. Tips. Best practices. Always inspect your data first. Use df, head, and df, describe, in Pandas to understand your dataset before modeling. Don't skip pre-processing. Even the most sophisticated model will fail if the data is poor. Start simple. Begin with simple models like linear regression or decision trees before jumping into complex neural networks. Use pipelines in Scikit-learn. They help streamline pre-processing and model building in one neat package. Document everything. Make your process reproducible with clean code, comments, and version control. Validate carefully. Use cross-validation and multiple metrics to evaluate model performance. Stay curious and experiment. Don't rely on a single approach. Try different algorithms, features, and metrics. And there you have it, a full deep dive into the core fundamentals of machine learning. We covered how to clean and prepare your data with effective pre-processing techniques, how to select and apply the right evaluation metrics for both classification and regression problems, and which Python libraries you should master to build efficient and scalable ML pipelines. These concepts form the bedrock of real-world machine learning applications, and they'll empower you to move from theory to practice confidently. If you enjoyed this video, make sure to like, comment, and subscribe to our channel. Let us know in the comments which topic you want us to cover next, maybe deep learning, model deployment, or a hands-on project walkthrough. Also, check out the links in the description for cheat sheets, code samples, and further reading. Thanks for spending your time with us today. and we'll see you in the next video.